Hello. So before we go and try to understand the buffer overflow attack, we need to really understand what actually goes inside the machine and what actually goes inside the memory of the this memory of the program. This is very critical thing that we really need to understand if we are going to understand all the memory corruption attacks. I won't go into much of the details. For more details, I would recommend you guys to refer to the reference link and the text that I have mentioned on the description box, so you guys can go and refer into that. Now let's go and try to understand what is memory attack. Okay, so understanding the memory structure. So basically, when we see the structure, it has five main components. The first one is the kernel, then stack, we have heap, we have data, and we have text. Now, the kernel. So this is the on the top of the memory, and it's the kernel area, which contains the all the command line parameters which are passed to the programs and the environment variables. For example, you are running a command, you're running a you're on a Linux machine, and you just happen to run a command called cat command with a file name. So those all of those operations are done on the kernel level. Now I know we can go through stack and heap and try to understand that, but let's try to to understand it through a bottom top approach. What is text? So this is on the bottom of the memory, and this actually contains the code, the actual code, the compile machine instructions of the program. And this particular area is a read only area because these should not be allowed to be changed. Now what happens in the text area and with the program is, for example, you have a, let's suppose you have a code, some random pseudocode. You compile it, you convert it into machine code, and these machine instructions are then stored over here. On top of the text is the data. Now, this is the area where all the variables are stored, whether it's an initialized or uninitialized. Let me just write it down as well. All of those variables are stored here. On top of data is heap. Now this big area of the memory where all the large objects are stored. For example, like so let me just write like all the large objects. So for example, like files, images, all of these are stored on heap. Now coming back to stack, it is just below, you can see that just below the kernel, and this actually holds the local variables for all of the functions. Okay, so for example, like you have I don't know, you write it down a function fun1, okay, and you int abc or whatever, so all of these things are stored in the stack. And when a new function is being called, these are posted on the end of this stack. Okay, so that's how it goes. Now you can try to understand more about this stack, how it works. Like there are a couple of things concept called LIFO, FIFO, and all those kind of things. So those are the another different concept that you can refer in the reference material that I have mentioned. But to keep it short and simple, we'll try to move on and try to understand these two basic terms and what actually happens in a program, like the stack and the heap. Okay, so let's see what happened. So for example, we have a small program. Okay, this is like, this basically does nothing. Okay, and you can see there are a couple of variables are there, right? And we have one k is equal to malloc, there's one more function that is being called. So when we try to divide the entire flow, we basically come up with the three structure. Like, we have like a heap, the stack, and the code. Now, code is the area where basically you store these things. So when you compile this code, these things gets convert into machine code, right? And this code is basically stored here. So yeah, in a way you can say this is a text area where all these codes are stored. Now in stack, you start storing all these variables, like you have a, b, c, d, k. Okay, all of these variables, pointer is there. So all of these things are there. So now what happens is, so all these variables, they have particular address. Let's say 1000 is 1000, maybe b will have like 1002, c 1004, and so on and so forth. So how does it work is, when you run a code, these memory locations are being accessed, and inside this memory there is some values that are being stored on these memory locations, and those things are being accessed, and then how the entire program works. So basically you can see that the thing is getting directly accessed, the memory is getting directly accessed on the stack through the code. However, on in the terms of heap, this is not the case. You cannot just directly access the heap how you did in the stack. So, for example, we have like and you for a heap you do it through a pointer. So, for example, you have this. Let's suppose you have like you have a pointer called k where some address is being stored about the heap. So let's suppose the address of this heap is ffbbcc, right? Now what happens in on the value of guess the pointer is that it stores this particular address. Okay, so you access this using the address of k, address of the pointer. Then inside this pointer you get another different address, and then you try to visit this particular address here, and then you access the entire content of the heap. So that's how you access the heap. So you're basically not accessing the content of the heap directly, but in an indirect way. And if you see here, uh, so these are the static, right? The stack stores the um, static variables, while in the term of heap you can actually have the dynamic ones. So now let's summarize between the stack and heap. So stack, the memory access is directly, while the size is static. The variables are basically used, so you use like int and all those kind of int a, int b, and all those kind of things. So you are basically using variables, while the case of heap you access it indirectly, while the size is dynamic. You you cannot just access it through variables, but yeah, you have malloc pointers, and those kind of things are there in order to access it. So I guess pretty much things are clear. Well, for more information, I would just recommend you guys to go and visit those resources which are present on the description box. So those will help. And now let's move on to the more pressing topic and the more important ones, which is like the buffer overflow attack. And we'll also try to see on we'll then perform these buffer overflow attacks as well. We'll try to take it to next level, and if possible try to also see the stack a heap overflow. So basically we'll start with the stack overflow attacks next. Thank you.